Dear students, so last class was the introductory class. I hope everyone enjoyed and everyone understood the topic sets. So what is a set? How do we represent a set, etc. We studied about some properties of sets. Now we go on to the next section of the sets, that is equal sets. Equal sets. Equal sets. When can you say that two sets are said to be equal? Two sets A and B are said to be equal if they have the same elements. They should have the same elements. For example, A is equal to set A, B, C. B is equal to set B, A, C. These two sets are said to be equal. A is equal to B. These two sets are said to be equal because they have the same elements. Order doesn't matter whether A can come in the first or second or third position. Order doesn't matter, but the same element should be there. Now, another example. Let X is equal to set 1, 2, 3, 4. Y is equal to set 2, 3, 3, 4, 1, 1. Are these two sets equal? Yes, one of you, two options are given. One of them said yes, the other one said no. But here it is an important point. When you write a set, if the elements are repeated, you write it only once. So what about the set Y? You can see that it is 2, 3 is repeated twice, but you write it only once. 4, 1 is repeated twice, you write it only once. So in this case, you can say that X is equal to Y. So two sets X and Y are said to be equal if they have the same elements. I hope all of you have copied the notes that is provided to you, so you can compare your notes and attend the class over here. So X is equal to Y. Now let us come to the subsets. Subsets of the sets. Subsets. Let A is equal to set A, B, C. What are the subsets of A? What are the subsets of A? The subsets of A are set A, B, C, set A, B, set BC, set CA, set A, set B, set C, and the null set. These are the subsets of the set ABC or the set A. Now, we can say, what do you mean by the power set? Power set. Power set of A. Power set means it is a collection of subsets. It is a collection of subsets. Collection of subsets. That is, in this case, a power set will be set of set ABC, set AB, set BC, set CA, set A, set B, set C, and null set. So if a set contains n elements, if a set A contains n elements, then the power set of A contains 2 raised to, you can take m, 2 raised to m elements. It contains 1, 2, 3, 4, 5, 6, 7, 8. That is, the set contains 2 raised to 3 elements, and that is equal to 8. But in a power set, you should note that each element is a set. Each element is a set. But subsets means subsets. Collection of subsets is called as a power set. Now, when you compare the subsets, we can understand some more properties related with the power set. That is, you consider this subset, set of AB is a subset of set of A, B, C. That is, it is a subset but not equal to set ABC. Then in that case, this is called as a proper subset. It is called as a proper subset. But when you consider this is also a subset, set of ABC is a subset of set of ABC. In that case, it is not a proper subset. Here, set AB is a subset of set ABC and it is not equal to set ABC. It is not equal to set ABC, so that means it is a proper subset. Whereas in this case, it is a subset but it is equal to the same set. So that means it is not a proper subset. You understand the difference? So we have studied about equal sets, subsets, power set and proper subset. Now, coming to the real line. Real line. You know what is a real line? Real number line. It contains integers, rational numbers, irrational numbers, etc. and so on. We have 0. To the right of 0, you have the positive values. To the left of 0, you have the negative values. Now, in a set, when you consider a set, how do you represent subsets on the real line? Subsets on the real line. Subsets on R. Subsets on R. Let us consider the real line. You are considering a small interval. Small interval this way, or it can be written in this form. A, B, which means the endpoints are not included. That means this small interval is contained in real numbers. This small interval is contained in real numbers, or this small interval is a subset of R. You can write this as A less than X less than B. That means the endpoints A and B are not included in the interval. This is a subset, but the endpoints are not included in the interval. Now, another one is consider the real line. Okay. Now, here A, B. This can be drawn in the form of real line A, B. That means the endpoint A is not included while the endpoint B is included. You can write this in the set builder form as A less than X less than or equal to B. A less than X less than or equal to B, and this is also a subset of the real numbers. Another one can be real line A, B, or A, B, which means A is included while B is the endpoint B is not included. For example, if you take this as 3 and 6, it contains all the points between 3 and 6. but 6 is not included. It starts from 3, but it comes to very close to 6. 6 is not included. Another one is subset on the real line A, B, or the same way it can be written as A, B, which means it is both sides are closed, and it can be written in the form A less than or equal to X less than or equal to B. Suppose this is minus 4 and 3, which means minus 4 less than or equal to X less than or equal to 3. That is, the endpoints are both included in that interval. So from the figure you can observe that all these four types are subsets of the real numbers. It is both are open. Here one end is open, other end is closed. Here also one end is closed, other end is open, both ends are closed. These are all subsets of the real numbers, which you require in chapter 5, linear inequalities. This is a very important section, so you have to understand this concept. Next one, we move on to universal set. Universal set. When you hear the word universal set, what comes into your mind? Universal set. When you hear the word universe, you know that universe, whole thing is included. Universe means everything is included. Suppose if I want to study something about a school. So I want to, I am a statistician. I want to study about the discipline of the school. I want to study about the results of the school, etc. and so on. In that case, I will consider that particular school as a universal set, and each class, standard 1, standard 2, standard 3, they are all subsets of the whole school. If I want to study the human population, some statistics about human population, I will consider the whole world as a universal set. So universal set means it is a bigger set. And all other things, what that comes under universal sets, we can consider it as the subsets. And universal sets are always denoted by the letter capital U. Universal sets are denoted by the letter capital U. Capital U. Now, when you consider universal set and subsets of universal set, it is easy to understand or easy to study when you represent them diagrammatically. And the diagrammatic representation of the universal set and the subsets was introduced by an English logician, John Venn. It was introduced by an English logician, John Venn. And he represented the universal set by a rectangular box. Universal set is represented by a rectangular box with a U on the right hand side. So U contains all the elements of the universe, and the subsets are denoted by closed circles. Subsets are denoted by closed circles inside the universal set. Closed circles. Subsets are denoted by closed circles inside the set. So this is the set A, set B and set C. So in the universal set there are three sets A, B and C. Now you can see that A and B are connected while C is an independent set. We will discuss about the universal set, the subsets and how they are all related, and moreover we are going to study about operations on sets. So first let us consider the universal set. Let us consider a small example. Universal set is equal to set 1, 2, 3, 4, etc. up to 10. That means I am taking the first 10 natural numbers. Let A is equal to set 2, 4, 6, 8. B is equal to set 9, 5 and 8. 9, 5 and 8. So n of A contains 4 elements. N of B contains 3 elements. Now I want to represent this one using a Venn diagram. Now first of all you will analyze the universal set. Universal set. So there is a rectangular box. Universal set. It contains the natural numbers 1 to 10. But before drawing,
this is a Venn diagram.
Venn diagram. It was invented by an English logician, John Venn. Now, the subsets 2, 4, 6 and 8, B, 9, 5 and 8. So, universal set contains all the elements. So, before drawing, we can see that A contains, set A contains 2, 4, 6, 8. B contains 9, 5 and 8. So, I will draw 9, write 9 and 5. So, this is A. B contains 9, 5, 8. 9, 5, 8. That means, for these two sets A and B, 8 is repeated. 8, the element 8 is repeated, but we write it only once. Common element, but we write it only once. So, but universal set contains 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The other elements which does not belong to A and B belongs to the universal set. So, the 4 elements 1, 3, 7 and 10 will come outside the set A and B. So, this is how you represent a universal set. Now, we have to study something. Let us consider one more example of the universal set. Let U is equal to set A, B, C, D. D, E, F. Set A is equal to set A, B. A is equal to set AB, and another set B is equal to set X comma Y. X comma universal set X, Y. I'll stand here. Okay. So, I want to draw the universal set. What about the universal set? A, B, C, D, E, F, X and Y. Universal set. What is the set A? Set A is AB. What is B? B is set XY. So, here we come across two conditions or two cases where in the first case we see that the two sets have a common element. In that case, the two sets A and B doesn't have a common element. So, what is the name for such cases, or how do we interpret those cases, etc. and so on. Now, here we can say that 8 is a common element. 7 I'll write here. 8 is a common element for both A and B. So, we can say that this part is called as this part, I can write it as A intersection B. A intersection B. And I will write it as A intersection B is equal to null set. A intersection B is equal to set 8. A intersection B is equal to set 8. That is one element in a set. Yes, very good. Singleton set. One element in a set, it is called as a singleton set. But when you consider this case, A and B, do they have any common elements? No, they don't have a common elements. So we can say that A intersection B is equal to the empty set. In that case, A and B are said to be mutually disjoint. Mutually disjoint sets. Mutually disjoint sets. That is, if the intersections of two sets are empty, then we call it as then we represent them as mutually disjoint set. Here intersection is A intersection B. Now we are going to study some operations, and let us consider what is the union of A and B. What is the union of A and B? A universal set. Now suppose we consider one more example. Now we come across intersection in the same way, represented by the inverted U. Now what is a union? Union. When you say about union, you know that you are collecting all the members, collecting everyone. So that is the union. Let us consider two examples. An example, A is equal to set A, E, I, O, U. That is the set of vowels in the English alphabet. B is equal to set B, C, D. B, C, D. One set contains 5 elements, the other set contains 3 elements. I want to find out A union B. A union B. It is written as A union B. It is equal to union. You have to collect all the elements. That is set A, E, I, O, U, B, C, D. A, E, I, O, U, B, C, D. This is called as the representation for union. All the elements are written. So one doubt may come. The doubt is, yes, very good. What is the doubt? Yes, suppose what happens if the elements are repeated? Yes, when the elements are repeated, you write it only once. Let us take one more example. Let C is equal to set 1, 2, 3, 4. D is equal to set 3, 5, 7. What is C union D? C union D is equal to set 1, 2, 3, 4, 5, 7. Here you can see that 3 is common to both C and D, but we write it only once. Here none of them are repeated, so you write all the elements just one time. So we can give a general formula, or what is A intersection B and what is A union B. A intersection B. What is A intersection B? Just now we have found from the diagram, A intersection B is equal to set of all x such that x should belong to A and x should belong to B. X is an element of A and x is an element of B. Intersection. It should be common to both A and B. And what about A union B? A union B is equal to set of all x such that x is an element of A, or here it is and here it is or x is an element of B, or both. But remember, always remember, we have to write it only one time. So this is called as union, intersection, mutually disjoint. Mutually disjoint means there is nothing in common to both the sets. No element is common to both the sets. Such sets are said to be mutually disjoint sets. Now we come to the next concept. Before coming to the next concept, let us just revise what we have studied from the beginning. What we have studied: equal sets. Yes, who can give me the answer for equal sets? Yes, equal sets are two sets such that they have the same number of elements. Subsets. Subsets means when you have a set, you write the same set, then decrease by 1, 1, 1, etc. and you get the set. That is called as a subset. And after subset, we have proper subset or the power set. What is a power set? Set of all subsets of the subset is called as a power set. And proper subset, you know what is the explanation. And then comes the two important concepts, union and intersection of sets. What do you mean by union of sets? You are collecting all the members. Intersection means the elements that are common to both the sets. Now, another concept we studied is about the Venn diagram, diagrammatic representation of a set. Isn't it? Diagrammatic representation of a set or pictorial representation. It was introduced by John Venn. It was introduced. So, the universal set is represented by a rectangular box. Subsets are represented by closed circles inside the rectangular box. Then we studied about how to get the union and how to get the intersection of two sets. Yes. Is it easy? Yes. And let me ask you, how many of you did the homework? I got the assignment. Yes. Except the students who came after school transfer, all others have submitted the assignment. Very good. So move on from the beginning. The whatever interest you have shown, it should go up to the end. All chapters are quite easy. Now let us consider the next one. Operations on sets. Operations on sets. Now, what do you mean by operations on sets? We are familiar with the word operation, isn't it? Where are you familiar with the word operation? Yes, in the case of numbers, when you studied, the operations were addition, multiplication, subtraction and division. In the same way, here you have to study the operations as union and intersection. What are the properties of these union and intersection? When we do operations on sets, that is when we find union of sets or when you find intersections of sets, the result is always a set. That is an important thing. When you do operations on sets, that is when you do intersection or when you find union, the result is another set. First one, union of sets. First one, A union B is equal to B union A. This property is called as a commutative property. It is called as a commutative property. If A and B are two sets such that A union B is always equal to B union A. Now we are dealing with union. Now for any three sets A, B and C, A union B union C is always equal to A union B union C. This is called as the associative property. Associative property. Associative property. Third one, A union null set is equal to A. A union null set is equal to A. It is called as the law of identity. Law of identity. Phi is the identity element. Phi is the identity element. Next one, A union A. A set A union with the set A, it is equal to A. And this is called as the idempotent law. Idempotent law. You should understand the word. What is idempotent? Maybe you will get a one word answer, or match the following or something like that. So A union A is equal to, it is called as the idempotent law. And the last one is universal set union A, which is the superset U. So when you find its union with A, you get the universal set. It is the law of universal set. Law of universal set. So these are the 5 properties of the 5 operations on sets, and with that comes the 5 properties. Commutative property. If A and B are any 2 sets, A union B is equal to B union A. Maybe they ask, prove the commutative property. So for that, A union B is equal to B union A. Next one, associative property. To prove associative property, you should have 3 sets A, B and C. What is associative property? A union B union C is always equal to A union B union C. And law of identity, A union null set is equal to A, because A is the superset and phi is the subset. So you get the bigger set. Law of identity, phi is the identity element. A union A is equal to A, and that is it is called as the idempotent law. Universal set union A is equal to U. That is the law of the universal set. Now in the same way, you have the operation intersection, and it also has some properties. Now as a note you can take down, if B is a subset of A, B is a subset of A, what does it mean? All elements of B are contained in A. All elements of B are contained in A. Let us take an example, then it will be more clear. B is equal to set 1, 2. Simple example. A is equal to set 1, 2, 3, 4. Okay. B is a subset of A. Then B union A, what it will be equal to? You can say that B union A is equal to set B union A is equal to set 1, 2, 3, 4, and this is nothing but A. So it is equal to A. When does that happen? If B is a subset of A, then B union A is equal to A. You may get questions from this part also. Next one, another operation is intersection. Intersection. Intersection, that means common to both the sets. Common to both sets. Now, what are the properties? Likewise, intersection also denoted by the notation intersection. Likewise, intersection also has, it is also obeys commutative property and associative property. For example, the law is A intersection B is equal to B intersection A, which is the commutative property. Commutative property. Second one, associative property. For any 3 sets A, B and C, A, B and C, A intersection B intersection C is equal to A intersection B intersection C. This is called as the associative property. Associative property. A intersection null set is equal to null set. Smaller set we get. It is called as the identity law. Identity law. A intersection A is equal to A. It is called the idempotent law. Idempotent law. Next one, universal set intersection A. It is equal to A. So when you find the intersection, you always get the smaller set. When you are finding out the union, you get the bigger set. You just keep in mind, intersection, smaller set, union, bigger set. It is called the law of universal set. Law of universal set. Next one more property is there. A intersection B union C is equal to A intersection B union A intersection C. This is called as the distributive law. For any three sets A, B and C, A intersection B union C is equal to A intersection B union A intersection C. So these may come as one word type question or to verify LHS and RHS and so on. I hope the properties related to the operations are clear to you. Yes or no? Yes. Okay, very good. Now we move on to the next section. Am I moving on very fast? Okay, you are comfortable with it. Okay, very good. Okay. Now next one is the difference of two sets. Difference of sets. Difference means subtraction. So subtraction means you should have an order. What is to be subtracted from where? So suppose if I say A difference B. A difference B denoted by A minus B. That is, from A you are subtracting B elements, which means set of all x such that x belongs to A and x not an element of B. That is the definition. A minus B. Elements should belong to A but not to B. But when I say B minus A is equal to set of all x such that x belongs to B and x not an element of A. X not an element of A. So this is called as a difference of two sets, and you should understand from where we are subtracting. The order is important. A minus B. That is, elements belongs to A but they does not belong to B. B minus A means set of all x such that x belongs to B and x is not an element of A. From this concept, difference of sets, let us take one example. A is equal to 1, 2, 3, 4, 5. B is equal to 5, 6, 7, 8. I want to find out A minus B. A minus B. According to the definition, elements that are in A but not in B. So what are the elements? 1, 2, 3, 4. Elements in A, not in B. Similarly, what is B minus A? Elements in B, not in A. That is 6, 7 and 8. This is A minus B and B minus A. One more example we can take. A is equal to, or let us change the name as V is equal to set A, E, I, O, U. B is equal to set A, I, K, U. Find V minus B and B minus V. It's a repeated question for the exam. V minus B. What does it be? V minus B means elements in V but not in B. What are the elements? Elements in B, V, not in B. That is E and O. Okay. B minus V. What is B minus V? Elements in B but not in V. Which is the element? It is equal to K. So it is a singleton set. This is how you find out the difference of two sets. From this we come to the next concept called the complement of the set. Complement of the set. Complement of the set. Complement always comes with the universal set. A complement. What is A complement? Suppose there is a set A. You have a set A. What is complement of A? And you have also the universal set. What is the complement of A? Denoted by A complement. A complement is equal to U minus A. And what is U minus A? Set of all elements X such that X belongs to U, X does not belong to A. Complement of a set. Complement of a set A. So there is a set A and you have the universal set. Complement of a set A denoted by A complement. A complement is equal to U minus A. That means elements in U but not in A. And an important property related to the complement is A complement, the whole complement is always equal to A. 2 times if you take the complement, the result is always equal to the same set A. We will just give a proof of that one. Do you need a proof of that? Okay, you do that as an assignment. This is an assignment question. A complement, the whole complement is equal to A. Now, next one related to the complement is if A and B are two sets. If A and B are two sets, then A union B, the whole complement is equal to A complement intersection B complement. And A intersection B, the whole complement is equal to A complement union B complement. This property is called as the De Morgan's law. It's called as the De Morgan's law. If there is a union, A union B, the whole complement is equal to, or In another words, A union B the whole complement is equal to U minus A union B. Isn't it? Elements in U but not in A union B. U minus A union B. And A intersection B the whole complement is equal to A complement union B complement. And this is called as the De Morgan's law. Now, so these three properties related with the complement is quite important. That is, twice if you take the complement, you get the same set. De Morgan's law, A union B the whole complement is equal to A complement intersection B complement. A intersection B the whole complement is equal to A complement union B complement. Now, so we have come to the, can anyone say what is A union A complement? What is A union A complement? Give me the answer. A complement. So elements in A complement means elements not in A. So what is A union A complement? Yes, it is a universal set. And what about A intersection A complement? Common to A and A complement. Will there be anything common to A and A complement? No. There will not be anything common to A and A complement. That is, A intersection A complement is equal to null set. Very good. So that means you are attending the class very well. Now, so we have almost come to the end of the chapter. We have to discuss some questions. But one more important thing I would like to introduce is just two more formulas. If A and B are two finite sets, if A and B are two finite sets, you know what is a finite set and an infinite set, two finite sets, then n of A union B is equal to n of A plus n of B minus n of A intersection B. N of A union B. Union means or. Either A or B is equal to number of elements in A plus number of elements in B minus number of elements in A intersection B means A and B. But one case can come in that case, formula. That is, suppose if A and B are mutually disjoined. Suppose if A and B are, note, if A and B are mutually disjoined, then A intersection B is equal to null set, or n of A intersection B, number of elements, is equal to 0. So the formula becomes n of A union B is equal to n of A plus n of B. If A and B are mutually disjoined, this is a general case, that is a subcase of it. If A and B are mutually disjoined. And the last one is, if there are three sets, if there are three sets A, B, C, n of A union B union C is equal to n of A plus n of B plus n of C minus n of A intersection B minus n of B intersection C minus n of A intersection C plus n of A intersection B intersection C. If there are three finite sets A, B and C, n of A union B union C is equal to n of A plus n of B plus n of C minus n of A intersection B minus n of B intersection C minus n of A intersection C plus n of A intersection B intersection C. You copy down these notes and next class we will continue the problems based on the operations and complement etc. and so on. Thank you.